Hi guys, welcome to Calculus. I'm Philip and this is
Olivia.
And we're going to be telling you about 1.3 exponential functions.
An exponential function is where f of x equals a to the x, where a is any number greater than 0 but not equal to 1.
However, there are some rules when you multiply or divide exponents. They are as follows in this little section. You can pause the video and write those down for future reference.
Examples of exponential functions are 3 to the x and 7 to the x.
Negative 5 to the x and x squared are not examples though. We're just going to erase those. Alright.
An example of an exponential growth function is when f of x equals 2 to the x. The domain of that function would be negative infinity to infinity, and the range would be 0 to infinity. An example of an exponential decay function is 1/2 to the x power, or 2 to the negative x. The domain of these functions is negative infinity to infinity, and the range is 0 to infinity.
Now, here is a real-world application for exponential growth. Suppose $100 is invested at an annual interest rate of 5.5%. To find a formula for that, you would use y equals p times a to the x, where p is the initial investment and a is equal to 1 plus the interest rate in decimal form. As the chart above shows, the equation would come out to y equals 100 times 1.055x. Another important thing to note is that the ratio from year to year is equal every time. As you can see, each fraction comes out to 1.055.
This is an example of an exponential decay function. The half-life of phosphorus-32 is about 14 days. There are 6.6 grams present initially. Part A. Express the amount of phosphorus-32 remaining as a function of x, which would be y equals 6.6 times 1/2 to the x over 14th power. Part B. When will there be 1 gram remaining? Plug in 1 for y. The solution is x equals 38.1 days.
Alright, so now we're going to move on to how to find zeros for an exponential function. And our example is 2 to the x minus 5. So in order to do this, you need to use a graphing calculator to find the zeros of the x-intercept. So if you don't remember how to do that, you can put in your equation under the y equals button, and then go to Graph, second, Trace, go to 2, 0, plug in a point that's below the x-axis, plug in a point that's above the x-axis, click Continue, and you get your 0 to be about 2.32. Alright, so now is the point in the video where we're going to give you a couple of practice problems. As you can tell, these are right from the book. Alright, so the first practice problem is question 1 from the book, and your task is to graph the function and state its domain and range. The function is y equals negative 2 to the x plus 3. For question 11 from the book, you have to use a graph to find the zeros of the function, which is y equals 3 to the x minus 0.5.
The answer to question 1 is the domain is all real numbers and the range is negative infinity to 3. The answer to question 11 is x equals negative 0.631.
Alright, thank you guys for tuning in. This has been P. Roos and the OC. We are signing off. Hope to see you guys again next week when we tell you how to deal with the number E.